I really appreciate the podium, because I think it's important to talk about these things, and I'm grateful for the organizers, especially the track lead Deep, for facilitating all of this. I think it's important to talk about it, so thank you so much. Who am I? My name is Massey. I spend most of my time looking like that. You might have seen my handle as Massey on GitHub, Filecoin, Slack, etc. I've had the privilege of working exclusively in this domain for about 2.5 years. I have background in P2P networks, specifically key-based routing. Currently, I work on content routing related problems. One of the projects you might have heard of is IPNI. And recently, I've been involved with content onboarding, which involves things like dstore, REST API, Boost itself, Singularity, and so on. Today, we're going to talk a little bit about the background, most of which Juan kindly covered, so I'm going to probably skip over most of that or go over it quickly. Talk about what this CommPact thing is, some caveats, and finally, my thoughts on the relationship between CommPact and IPLD and IPLD itself as a project, which I, for one, feel very passionately about. What do I want to get out of it? This is a snapshot from Molly's introductory talks to the opening talks to the whole summit. The main thing that I want to get out of it is explore ideas together. I am embarrassingly aware of my lack of knowledge in a lot of areas, and I think this is a great opportunity to have everybody from different domains to talk about these things and just explore different ideas of how to do things. So if you think I'm here for building relations, think again. I'm not going to, no, I'm joking. Of course, we want to do all of that, but we want to concentrate on exploring ideas. This is a screenshot from Filecoin piece, specification of Filecoin.io. So that URL takes you to spec.filecoin.io. The key thing to point out here is the definition of piece. Piece is an arbitrary sized thing. It's just a capsule for conveying users' data, and then it fits into things like sectors. Sectors may be different sizes, different SPs support different sector sizes. The main thing to point out here is that the unit of representing users' data in Filecoin world is Filecoin piece, and there are accidental things like the sector sizes today that make it mostly look like 32 or 62 gigabyte sizes, but technically this is an arbitrary thing. So I want to focus on separating the lower level Filecoin primitives like sectors from how we convey information as a user that wants to use the Filecoin network. And I want to concentrate on the Filecoin piece itself, right? This is, again, another image from the Filecoin piece, Filecoin spec. Specifically, we want to talk about these two areas. So this basically shows you the life cycle of raw data as it's presented by the user and how it gets converted into a piece, which then gets into a deal, and so on and so on, right? So we want to talk specifically about PieceCIDs, CommPs, also known as CommPs, the intermediate stages of PieceCID generation, and then where the payload card thing comes in. If you look at that page on Filecoin Pieces that the QR code points to, this is the 3 steps that you see on top of the page about data preparation. So it talks about how you generate the DAG and so on and so on. I'm sure most of you are familiar with these steps. I want to skip ahead and notice on one of the important notes that is at the bottom of that page, which talks about separation between implementation of Filecoin as a protocol versus Filecoin as a protocol itself. It so happens that there are a lot of things that we deal with today which are specific to Lotus implementation, which are specific to Boost implementation. I think it is important to separate what do we want from a protocol level in terms of interaction with a decentralized storage network versus accidental complexities that exist for pragmatic reasons or whatnot in a specific implementations. There is a sentence at the end of that screenshot which says, as long as this is the case, implementations can deviate from the first 3 steps above, right? So if the spec is up to date, I would probably argue that car file is not part of the Filecoin protocol itself. Car file, it so happens to be the incarnation of IPLD DAGs the way that we archive them today. That is not to say that Filecoin protocol doesn't require IPLD DAGs, right? That is to say that the way that we so choose to encode IPLD DAGs on disk happens to be car, carb1, carb2, pick your version. Having .car files on Filecoin does not mean, is not part of the protocol. That's how I read this spec, right? So.
I'll ask you a question from Juan.
Sure.
So just strong disagreement there. That I don't know how that line evolved. Doing that is going to cause a software explosion that we don't want. So before you write any other ways of storing the thing, and you allow a bunch of software to use it, write the thing that is going to portably be able to run many versions of that, and put that everywhere before you start admitting different ways of laying it out.
Maybe I guess, yeah, one thing on that is, yeah, at the very least, like an identifier, a number, even if there's not going to be any WASM, like a self-descriptor would be great. But also, this sentence, reading it, is a little sketchy in the sense that if you do this without the FR32 padding, things start collapsing, because even right now, you have no way of identifying. Like the hacks that are proposed for how we deal with this now just assume FR32 padding.
Right.
And so I don't even, maybe with car files you could say, okay, well, we could do something else. I'm not convinced I'm not convinced the FR32 padding part of that sentence is optional. I don't know if anybody else is, but that feels non-optional.
Right.
It is not optional, but it's also not set in stone, because a different proving system will have a slightly smaller window, so the FR32 will not work. FR31.5 will be necessary, something like that. But yes, some kind of payload extrusion will always be necessary, given how snarks work today.
Right. And I think that PieceCID wants to emphasize that in that sentence, in that you need a way of verifying that the data that I receive as a storage provider is the same thing that you gave me, right? And that is basically PieceCID.
Yeah, except like the current PieceCID, the hash is that it ignores the existence of FR32. It just sort of says like, yeah, it's like SHA-2 is all the way down. Don't worry, it's gonna be fine. Which it's not. And so the reason that I think that the sentence was able to say no FR32 required is because it's like, well, yeah, as long as it's valid and it translates over to the other space when you do the proofs, like no FR32 needed.
I mean, it says achieved in different ways.
Yeah. I feel like the example there might be, we may need to delete that example from the spec.
Just remember that the spec is a mishmash of a bunch of opinions. It's not actually a spec.
I think that's true about all specs in the world.
We should rebrand that.
No, but some better, like we should move the Filecoin spec into something closer to what IPFS has done, which is to have a bunch of different sub-specs that then you have like compliance against. Right now, having all of the thing as one very large document, without the ability to have that set of distinctions, makes it a bunch of different opinions that do not reflect what everything must do.
Thank you. Any other questions? Anna?
I think it would be interesting, sorry, like, my view of, is this on? Yeah, okay. My view of a better spec for Filecoin would be the functioning of the blockchain and the associated FIPS, right? Which is much more limited even than this. Like, none of these opinions, like, and because like, my understanding of most blockchain systems is you design it to set up certain incentives for certain types of behavior to be incentivized, and you expect that if you do not incentivize that behavior, it will not manifest, simply because you say, this is my opinion, is not gonna have any effect. So, I mean, I'm just wondering, like, car files, whatever, IPLD, like, these are all opinions. They're not part of the incentivization structure. So I don't understand why, like, to me, it's like, in practicality and reality, it's a decentralized network that's going to operate according to the rules it was set up by. And one of those rules was not put things in car files. I mean, you could write it, but it's in some of the working software, but anyone could modify that software and, and then have it operate how they want. So partly for me, it's like, I don't know, we can argue what's right all day long, but the incentives are the incentives, and carifying is not one of them.
So that's a good thing to add a FIP to / on not adding car files.
That's what you mean. Okay.
I think so.
To me, like, that's what you need to do.
Or not allow that thing. You have to like prove that it's well laid out. So just backing up for a moment, if we had a better POREP, we would have a POREP on the raw IPLD data without the car files, just the graph. Like, this is possible. We can get zero knowledge proof oriented things that can give you verifiability over arbitrary IPLD graphs if they're fixed size. Building those POREPs is hard, and so we don't have them today. As computing gets much faster, or rather, we can make a POREP like that, but it's not going to work well with the hardware today. As computing gets faster, that's going to be easy, and this entire proving tree is going to be thrown out the window. There's an entire thing that's needed only for a period of time, and what we're going to end up with is just verifiability over the raw hashes that the applications want. Backing up for a moment, yeah, there's a lot of things in the protocol in general that are not checked by incentives. There's guidance of what is going to lead to good times or bad times. And so, for example, we're not going to add support in a bunch of places for arbitrary things that don't follow guidelines. And so the guidelines are for enabling a lot of software to interop. Will disagreements form and different groups do different things? Yeah, totally. It'll happen, and that's normal and part of the thing. And if it's successful, great. But deviate from the recommendations at your own risk. This is why the IETF specs tend to say must, should, and may, and so on. Like, you can deviate, but do so at your own risk, and then don't go around complaining that things don't work, because yeah, they won't work because other things won't match up with that. That's kind of like that's the incentive for complying with the protocol, or complying with the pieces, is enabling a lot of other software that other people write to interop. And so you can go do your own thing, sure, but you're gonna pay a cost for that.
Yeah, all I'm saying is that it just seems like we're assuming, who is we in this scenario, right? Because reality at this point is Filecoin is a collection of entities using it and trying to build businesses off of it, and they're going to do whatever they so choose largely for themselves as self-interested actors, according to the rules that can't be broken. And then if you want a rule that can't be broken, you need to introduce a FIP. So you're going to have to build agreement among everyone that yeah, we should totally make everything IPLD graphs. I mean, I don't know. Yeah, that sounds. People couldn't agree to extend the sector lifetime. It seems challenging, but yeah, I don't know. I'm just saying it's a decentralized network with decentralized entities, companies building in it. It's not even per se a spec process, right? It's a little different. Yeah.
There's hundreds of companies writing software following recommendations. So there will be a lot of deviations, but there will be some recommended things that will be portable across those. And so what I'm saying is, if you deviate from that, then you won't interrupt with as much of the things. And sure, can you do it? Probably. Are you going to have a good time doing the thing that you want for your one use case? Great, yeah. Are you then not going to benefit from all of the other pieces of the stack that are going to emerge along the way, or that have already emerged in other parts? Also, yes, and you're going to have a bad time there. So for example, when we write a bunch of collections on chain, when we write perpetual deals, when we write aggregators and so on, there might be things that just won't work with your formulation.
So I guess this talk fits into this spectrum as a way by which you could potentially have the best of both worlds as long as you understand the caveats. That's what I want to present here today, right?
A huge caveat to all of this is just WASM the whole thing, and then like no arguments anymore. Like just run WASM everywhere, and not a big problem. And we should be booking it as fast as we can to that.
I have a very quick question on the POREP over IPLD graphs. Everybody from the team who is working on new POREP is telling me that proofs over arbitrary IPLD is not possible in the near to medium term. How do we reconcile this mismatch? Because you are saying, oh, we have it practically tomorrow.
I didn't say practically tomorrow. I'm saying as hardware accelerates, which usually means a doubling every 2 years. So if you're paying like 1 or 2 orders of magnitude, that's that many doublings. So it's not tomorrow. It's not the short or medium term. It's the longer term. But that's where. So I'm trying to describe a concrete time point at which all of the proving tree and so on that we're relying on now is going to like hopefully completely disappear. Not just change into something else, completely disappear into just proofs over the existing graphs.
Is it fair to claim this as a timing thing in a sense then, which is like we're operating off of a hypothesis that at some point in the future things will get drastically better for things that comply with IPLD and a car file structure that we are designing towards today. But then what we're hearing from attempts to find solutions that have product market fit today, or feedback that we're getting from users that are using the system today, is that they don't actually care. So maybe optimizing for a near-term use case with a near-term solution that doesn't comply with these things because these things haven't landed yet and don't actually benefit that user at this point in time. And given that we don't actually have a defined point in time for that, maybe it's not the worst thing to make a slightly nearsighted decision in this term to deliver value and expand the value of the network.
When IP was introduced, there were 2 really annoying things about it that people didn't like. One, it was overhead over your local network protocol, and people said, this is stupid, why do I want to do that? Just implement support for my protocol. That didn't last very long. The second objection was, why write an entire congestion, like why write another protocol on top of this one? Why are you giving me 2 protocols, TCP and IP? And that was about the entire protocol suite and paved the way for dozens of other protocols to be built. So sure, you can not do the thing, and that's okay. Go have fun. I predict you will have a very bad time in a while. So like, you can just choose not to listen to me. That's fine. Like, lots of people don't. They have good times and bad times.
Yeah, makes sense. Akardi?
Maybe you can help me understand how, given that we're going to have to throw away all of the sealed sectors if the POREP changes, how that differs from a use such as Maciek proposing. That also
I haven't done it yet.
Not, sorry, yeah, I'm trying to be quick. Okay, I'll just table this question and return to the presentation.
I'm grateful, Prophet. Okay, thank you. I have a slide coming up later on, which is a great slide over which to have this type of conversation. So I'm going to quickly just talk about stuff, and many of you know what's coming, but as soon as we cover that, I think we can open up this space for further discussion. So I guess going back to the background, there are 2 things that I see value in car files specifically. And when I say car files, I do not mean IPLD DAG. I mean an incarnation, a very specific incarnation of IPLD DAGs today. I must express this all the time because, in my opinion, IPLD DAG is far more abstract and far more powerful than its incarnation today. So we need to make that separation in our mental model, I think. So it serves 2 purposes, I think, today, which is isolates Filecoin implementations from application. It also gives you wider ecosystem integration, the value add. What makes Filecoin different from the new decentralized storage system? Right? This is why they're like IPFS integration, you know, getting files out of Kubo, for example, and all the nice things that come from. But what happens on the ground when we actually do this? So if I have data, I turn it into car files because that is required to make deals. Then I make a deal proposal that gets accepted or not accepted. In the meantime, I have to keep this car file around, basically. Right? I keep this car file around. What really happens, what happens in most of the times is I'm storing my data and its car form. The time it takes to make deals could be in hours, could be in days, unclear. And then when that happens, great, I can finally get rid of my car and just keep dealing with my data or potentially get rid of my data. Then when I want to get my actual data back, I get car files back. I have to turn it back into my data, so there's like clear overhead here, right? That means in order to make deals, in order to upload data onto Filecoin and download data from it, there may be need for optimization, like, for example, caching. Right? If the deals happen to get slashed, like 10% of deals that I'm making as a giant MSP or ISV gets slashed all the time based on the pool of SPs that are available today, then I don't want to compile car files all the time. This is all IOPS, this is all storage. So I probably need some caching. I need some transformation toolkits. I need to worry about the efficiency of those transformation toolkits. I need to worry about standardizations and like all series of things. At the end of the day, what I really want from user's perspective is that thing in the double quotes, which is my data, right? So introducing car as an abstraction of, as a way of conveying IP literags into the network clearly has costs, right? So one area that I think we should be working on is to reduce those costs. There are many different ways of doing it. There is another thing in the car file, about the car file representation is, if you have a blob of data, something that inherently doesn't have an IPLD shape, for example, what is the difference between turning it into a car file or versus having a different format that just essentially chunks it up, and for each of the chunks gives you a hash, or what we like to call a CID or context, right? The benefit of turning it into a car is not exactly clear, and benefit of turning it into a car, in my opinion, entirely depends on the original shape of the data for the end user. Right? But we still want content address data. Right? I am in the opinion, sorry, Bill. Go ahead.
I wanted to give one benefit, which I think is there, which is think about, you know, future Filecoin deals of different shapes, right? So you get a different POREP that doesn't need 32 gig deals. And so if you've got your big blob of your terabyte of data and you've chunked it into your 32 gig cars, is Filecoin in its replication to a new thing that no longer has 32 gig limits able to repack and resize that data? And if it's raw data, then there's some application layer thing that is going to be involved in how that goes from 32 gig chunks back to now 100 gig chunks. You've sort of repackaged it, and you have to know from the raw blob, okay, this isn't just the exact same 32 gig. If we've done the car chunking in a very application agnostic way, in the layers Juan showed earlier, Filecoin could now redo those sizing. So it does give some power into the Filecoin system to do stuff. So there is some benefit in there beyond just the...
The only thing I would add there, I completely agree with you, Will. But the only thing I would add there is that chunking car files is not the only way to chunk data. There is certainly benefits in chunking full stop, just simply because there's a heterogeneous set of nodes out there with different bandwidth, different requirements. So we absolutely need to maintain the ability of chunking, right? What's the sort of point here that I'm trying to make is car as a vehicle of chunking data is not necessarily the only one or the best one in every case, right? I actually have a slide on chunking that comes up in a minute. But thank you so much. It's a good point.
I recommend everyone go look at the implementations of distributed file systems at scale and the implementation of large-scale databases. So things like Dynamo, Bigtable, all the things that led to things like the Parquet package spec and so on. Like large-scale systems have many of these layers of wrapping and unwrapping that happen. And that goes even in your IP packets. Your computer sending IP packets, your IP packets get wrapped and unwrapped into jumbo packets and so on through the ASs. So the process of taking some data and wrapping it and enveloping it in something else many times happens layers and layers and layers and layers deep. And the entire internet is just a big machine of moving across those layers and constantly transforming. Yes, is this annoying? Does it add some extra work? Sure. Are computers really fast? Also yes. Can these implementations get faster? Also yes. Can they get smarter to understand the user's data and not just chunk on some dumb version? Because right now most of the chunking is like just arbitrarily grabbing something and just splitting it and chunking it that way. That is a terrible way to do it. You don't get utility out of that. Try to build into the IPLD graph the mapping of the application data. So you can do what Will was saying.
I 100% agree. And the point here is most of the chunking is that dumb chunking. And the value add doesn't come across. Like right now, turning stuff into car files with dumb chunking mostly comes across as placeholder. There's an argument to be made that this placeholder is necessary and good to have. But the argument I'm making here is there is a degree of pragmatism. So what timeline are we optimizing for? If we are optimizing for something that is that's going to exist in 10 years' time, then we're talking about a network that itself is almost 10 years old. That is a very long time, right? So the point of this talk is to provide a way by which we could have trade-offs.
We should actually just proceed with your talk for a few minutes.
Just to be clear, so we've discussed some of the things that are 10 years out. Most of what I talked about is now and 2 years out. There's hundreds of companies building software using IPLD graphs, not using this other stuff. So break compatibility at your own risk.
Thanks, Juan. So simplifying the data onboarding. That's what this talk is about. What if we could remove the need for data preparation completely, still keep the chunks, incremental verifiability, and still keep it content addressed? What if we could do that? Now, I want you to think about what if there was a hash function that took bytes and produced for you a list of CIDs. For a given chunk size. That means I don't need to change my data at all. I sort of get an IPLD representation, which is as much of an IPLD representation as that dumb chunking thing, right? What if that hash function existed? So from this point forward, I want you to think of the stuff that I'm going to talk about as a hash function that it so happens to be called CommP, which so happens to be the same one that's used in Filecoin. Turns out this hash function thing exists. It's called CommP. It generates a hash for whole of your data. In an intermediate state, it generates a Merkle tree of nodes that are made up of just SHA-256 hashes. They are in fact addressable by CID. There is already implementation of this hash function that literally give it data, gives you back hashes. So the grand idea here is that I can project a representation of an IPLD DAG via a function. And that then frees me from tangling it in with the representation of data on disk, right? The main thing to point out here is that this, in my opinion, this is an opinion, this is not a breaking change. Because IPLD itself is abstract and loose enough that allows you to work with data and DAGs and so on. There is still hashes here. There is still content addressing here. What is different is the forcing, is tangling IPLD encoding on wire or disk or changing the original data format in the name of compatibility with IPLD. Because there's nothing stopping me from having a specific implementation of IPLD that takes arbitrary bytes of anything, cat picture, and then allows me to browse it as a DAG. Right? So that's the grand idea. So I think
just want to, I just want to point out, this is that last sentence you said that like I can take my cat picture and I can reference it with the PieceCID and I can render it. It's like a very specific opinion that to deal with like the broken PieceCIDs, like we have several options to deal with. Like that's a stronger opinion than I've heard some say, which is to refer to the pieces as like the whole thing, including the padding. It's not a bad opinion. It's just a strong opinion, which means that that's something we have to deal with as we go forward.
Right. I think you see the beauty of IPLD and so on for me is takes away the back and forth on what hash function did you use to verify your data? Okay, you got to tell them the hash function to do it. So that's why there's multi-format, for example, right? That's the problem I don't want to solve. I just want a CSV table that tells me what code it is and I do it, right? Then part of it is about linkage between these pieces that are verifiable, and then a whole ecosystem that could be built on top of it, which in my opinion, over time will be extremely powerful, and this is why I encourage companies to invest in this, because this would be the differentiator in the future, right? But also, in my opinion, that does not mean you have to re-encode the zettabytes of data that is out there to be IPLD compatible. I think we can solve that at a software layer, at least in specific examples, right? Sure, there might be specific cases where you have to change your data simply because virtual representation is too expensive or whatever, right? But what is missing right now, in my opinion, is spectrum that allows you to do these things. We don't have enough tuning knobs, right? We have one shape that says, okay, is it car yet? Can I read it as a car? Is it not? It's not. It's not IPLD, go away, right? And that's a great first iteration of implementing this thing, but I don't think we should stop there. We're talking about integration with all sorts of flavors of data, and to some extent, I think it would be unrealistic to require the world to re-encode their data completely. I think eventually they should want to do it for their own good, but they shouldn't be forced to do it in order to use a decentralized network that could today project a virtual view of an IPLD DAG, which enables millions to not re-encode their data and just upload it.
So to follow up from Juan's previous talk, right? So CommP and CommD, these are like Filecoin guts.
Mm-hmm.
And it sounds like the main thing you're advocating for is like the simplicity of dealing with a flat set of bytes, right? Rather than the fact that like I don't have to do a second round of hashing. It's like the complexity of the slicing and the ordering and the fact that you have all the bytes from your file are now intermixed with the hashes in between them. But if you wanted to resolve like Juan's concerns about please don't couple to the Filecoin guts because they will change and then you'll be sad, you could just say like, okay, Blake 3, right?
So I have a slide on that one, right? So like I said, I would love everybody to think of this as using an IPLD DAG with a hash function, which so happens to be the same hash function that Filecoin uses to make deals.
Sorry. Can we actually just limit interruptions now till the end of the talk? Because we have to give up this space to reconfigure the room in 10 minutes. So I'm going to ask for no more interruptions till Masi finishes. And if we have time permitting, we will take them here. If not, we will just continue the conversation, just not physically here. Sounds good? Thank you.
So this internal structure inside this hash function, which we call CommP, has a Merkle tree inside with layers. This tree has layers. And those layers basically give you a way of chunking your data, right? for a specific for a specific chunk size, it gives you a set of CIDs that can verify your data. Right? There's obviously like stuff that I didn't talk about, which is you need to know this size and so on, but we'll get to that in a minute. I think that's more of like a side lookup problem. I have a separate slide for that. But there are a set of nice properties here. So this layering would not only allow me to specify a set of CIDs for a chunk data, but it gives me different chunk sizes for my data. So, oh yeah, maybe I have a separate slide on that one. Yep, so I'm gonna go a bit faster. So this, what CommPact provides you with is, leans into this idea of CommP as a hash function. I'm gonna talk about what it also provides, which is varying chunk sizes. Going back to Will's question, I'm also gonna talk about if we use CommP as a hash function, how are we gonna look stuff up? Because we already built this whole ecosystem about accepting car files, indexing car files by ISPs and so on. If we do this, if we don't have to change our data at all, then what the lookup looks like. And finally, this retrievability, right? How are we gonna retrieve stuff? So leaning into CommP as a hash function. So we have a PieceCID that is produced by Filecoin. It's a way of confirming that the data you send to the network is the same one that is on your disk. Internally has a Merkle tree structure. The main thing to point out is that each of the layers, the nodes in each layer could be used to then deduce the original PieceCID, right? So it provides me a way by which I can infer that you gave me a list of CIDs that corresponds to a PieceCID, right? Without talking to anybody, right? If you give me a PieceCID and a list of CIDs, I can infer that these two are, from the same tree. So that it also allows, so the presence of layers also allows me to have different sized chunks, for example. So in a layer 17 of this tree, you end up with 256 kilobytes chunks, right? Which in total made up of, whatever the number of hashes is that's on the screen. And those number of hashes would then allow you to incrementally verify your arbitrary bytes as chunks of 256 kilobytes. Now, you can move into this tree. So you can imagine layer 15 gives you different chunk size, different number of hashes. Layer 5, for example, gives you 32 hashes that allows you to verify data in one gigabyte sizes. So what there's this very subtle property here. What this allows you to do then is mix and match chunk sizes. That's quite an interesting use case in my opinion. So right now, if I generate a car file, I have to pick a chunk size. We are talking about that dumb chunking thing that most of the times happens. I pick a fixed chunk size, and if I want to change that chunk size because suddenly there's a mobile application that's using my data and needs a smaller chunk size or big chunk sizes, essentially it means I have to recar my data. I have to make a new deal. What CommPact proposes is that we are separating, we are pre-computing these SIDs, or have a way by which we can infer them, and that frees us from redealing the data completely while allowing varying chunk sizes. So you can dynamically change the chunk size at runtime without changing the data at all, the payload of data. So there's been discussions about retrieval verification over the track, so I've changed these slides slightly. Another thing to point out is that using CommPact, because it frees you from the format of data that is stored on Filecoin, then it allows you to verify any data no matter what in terms of retrievability on the network. So if tomorrow we change the format, we allow .jpeg on the network, or we change a new car file or whatever, you don't need to change, you would have to change the retrieval verification ecosystem to understand this new format, right? Whereas if we rely on this specific hash function, which on purpose so happens to be on the same hash function used by Filecoin, then you don't need to change anything in your code. It just works because it works at the Filecoin protocol level rather than the implicit assumption of format of the payload deals. So how are we gonna look things up, right? As I mentioned earlier, I've been involved in the IPNI protocol project a lot. So this is what I came up with in terms of integrating this intermediate layers into a lookup mechanism, which looks just like looking up any CID, so there's no specific difference here. It's going to use the existing lookup mechanism. You can imagine, so in IPNI you have advertisement structures which produce a chain of IPLD tags that represent the content exposed by a node. There is extensibility built into IPNI to allow you to define your own formats and things in the form of metadata field. So metadata field in IPNI just accepts arbitrary bytes. So in order for me to look stuff up by that PieceCID that I've made deal with and those intermediate CIDs within it, right? I could use IPNI to find out the list of CIDs for a specific layer along with some other metadata, like for example size that is missing right now, it's not presented in the PieceCID itself, right? To then infer what request I can send to an SP to get that exact piece of, exact series of raw bytes, the hash of which corresponds to the CID. And the translation, so I'll get to the translation in the retrieval side, but this slide just shows you an idea of how you could use existing protocols like IPNI to advertise this IPLD DAG representation, right? Which then enables retrieval, right? There's a nice added benefit here, which is the verifiability that I mentioned earlier. This today doesn't exist. So today, if as a storage provider or index provider, you're just advertising the list of CIDs, right? An indexer just accepts it. So okay, you say this, fine, right? And then there's a separate process that potentially goes and retrieves this, which is the retrieval bot and retrieval verifiability, sorry, retrieval incentives and so on, all these tracks talked about. Using Merkle tree has a nice benefit for indexing, which is given a list of CIDs and a PieceCID, I as an indexer on my own can verify that the list of CIDs you gave me indeed corresponds to the PieceCID. And using PieceCID, it has another benefit for the indexers, which is they can verify that this thing is on chain, it exists, right? So right there you have a nice kind of setup for perhaps removing some of the attack vectors in the indexing process. Right? So that's another wild idea, but I've written it as like a, you see symbols here. I use a symbol of gift, which is this would give us this gift, but ideas, these are, think of them as hand-wavy thoughts right now, right? It's just to plant some seeds. Retrieval, how are we going to get the data back? So here I present to you with two approaches. One is inferring how we can, inferring the right HTTP request to send in order to get data back. And that is essentially finding the metadata on IPNI and then turning the request into the existing HTTP endpoint exposed by most SPs, I think, or some SPs that allows piece retrieval. Time check. Okay. Piece retrieval, so you can use that to translate the request into piece retrieval. Or if we are willing to add a small component into Boost, for example, we could have this CommPact server that understands intermediate CIDs from a piece from this CommP, and given a CID, would directly return data to you, right? So it just depends on how much we want to do this. But from technical perspective, it's just important to point out that all we're talking about here is just a retrieval library implementation, which is no more complex than the existing retrieval library implementation that we have today, which is Lassie, right? If you have a smart client that makes specific interactions, you get data back, it is all content addressable, right? It's just the way that we construct this IPLD shape is different, it's virtual. Caveats, if you want to use UnixFS stuff, don't do what I'm telling you. This is not for people that are benefiting from UnixFS DAG representation. If you're doing the right thing and not the dumb chunking thing, you should not do this at all, right? You should go and lean heavily into IPLD specific implementations, IPLD specific features, right? But if you're an application that is not doing that, you just want cat pictures in and out, you don't care about IPLD, right? This talk gives you an option, right? Which maintains compatibility with the wider network, at the same time frees you as a user that doesn't care about from paying for the stuff that you don't care about. Just a few more points and I'll stop.
Sorry,
So
thank you.
what happens if CommP hash function changes? What happened to MD5 becoming a really bad hash function, right? This is a hash function. We are building systems that are supposed to accept interchanging components, right? We are simply talking about a hash function here. Is it perfect? Obviously not. Sure. Like what's wrong with that? So if the CommP hash function changes.
Can we take this a second? Sorry.
So I guess the point I'm making here is that the worst case, if the CommP changes completely, right? First of all, we don't know the migration path there. It is unlikely for all PieceCIDs to go away overnight. There's a long process here. And the second one is from data preparation side, we simply go back to where we are today, which is to hash data twice. And that is assuming the new way of making sure that the data sent by the user and data received by the server does not use hashing at all. And I think that's a massive if, right? There's got to be some kind of way of verifying. It might not have internal tree structure or a Merkle tree, but the worst that could happen is if you're using this approach, you just keep doing the CommP thing, use your hash thing, everything would just work. You're back to hashing data twice, right? And this is the long timeline. Yep.
See, thank you.